Today's exam question comes to us from the 2020 November series, and it's from the paper one higher tier. And this one really concerns equilibrium and Le Chatelier's principle. So if you're struggling with that, hopefully this should be of help to you. So the question is about a reversible reaction. The reaction between the solutions of iron 3 plus, and thiocyanate, SCN minus ions is reversible. And the ionic equation for the reaction is shown below. And we've got these colours here. The colour of the equilibrium mixture is orange at room temperature, which makes sense because we've got some yellow and some red, and that's how we're getting the orange. Give the name of the solvent used to dissolve the ions. So nice quick opener. We can see here from the state symbols we've got AQ. And AQ says that it's an aqueous reaction. AQ means it's an aqueous state, and therefore the solvent is water. A few drops of the colourless solution containing a high concentrate of thiocyanate ions is added to the orange equilibrium mixture. Explain, so remember, explain means we need to say why, the colour change observed. So this whole kind of question hinges on what we call Le Chatelier's principle. And it's so important for the whole question that we're going to write it out at the top. So Le Chatelier's principle says that the position of the equilibrium changes to minimise a change. You can also call that offset. I like to think of Le Chatelier's principle as basically like saying you've got an annoying 5-year-old sister or brother. If you tell them to stop doing something, it makes them want to do it more, okay? Le Chatelier's principle basically says if I'm changing some kind of factor about the reaction changes to try and minimise that change, try and reduce that effect. If I am adding more thiocyanate ions, right, that means I'm increasing this amount. Le Chatelier principle says that we move the equilibrium in order to reduce that change. So if I've increased this, our reaction wants to decrease it. So the way it's going to do that is by moving the equilibrium to the right, making the forward reaction more favourable, and meaning that we go over towards this side so that we offset that change that we've just done. So if I increase the thiocyanate ions, that means our reaction moves to the right and makes more of the product. Now, as that product is red, that means that the solution is going to turn redder. Okay, so let's put that together into an answer. So the solution becomes redder. Why? This is because the equilibrium moves to the right. Why does it move to the right? In order to reduce the concentration of thiocyanate ions. That whole thing is called Le Chatelier's principle. Now the next question gives us an opportunity to practice that concept again. A water bath is set up at a temperature above room temperature. So what that means is we are increasing the temperature. When a test tube containing the orange equilibrium mixture is placed in the water, the mixture becomes more yellow. So if the mixture becomes yellower, that means we're moving across to this direction. So it says, explain what this shows about the energy change for the forward reaction. If I'm increasing the temperature and it causes a backwards reaction, that means that due to Le Chatelier's principle, I want to reduce the temperature, and the backwards reaction is going to reduce the temperature. If the backwards reaction is reducing the temperature, that means that it must be an endothermic process. What that also means is the flip side is that the forward reaction must therefore be exothermic. So let's put that together into an answer. The equilibrium has moved to the left. Why has that done that? It's done it to reduce the increase in temperature. That's the idea of Le Chatelier. Why is that the case? This means the forward reaction is exothermic and backwards endothermic. So the next part of this question says, explain why changing pressure does not affect the colour of the equilibrium mixture. So pressure is all to do with gases. And if we look at our state symbols, these are all in solution. So there's no gases present. So what that means is there's no change in equilibrium position purely because there's no gases.